Thank you, Phil. The pleasure is certainly mine. And I have to thank also ILSI for making me part of the family for a long time and still being part of that. And I think I was told to talk about the steps towards precision nutrition. And I imagine that, yeah, that was a good representation. Steps on the beach. And the other thing is that I put precision nutrition there with the sun, and you can interpret that as being blinded by the objective or the distance of the sun in terms of reaching the objective. The other thing that we have experienced, those of us that have been in precision nutrition or whatever we want to call it for a while, it's probably this, help, this, no. I need instructions.
Just use the remote.
Oh, the other gadget. Well, some people lose the baggage in the airport. Some people leave the brain in the airport. Okay, anyway. So you see, there are many steps on the beach, an indication that the precision nutrition is crowded. And that's something that didn't happen when we started years, decades ago. The beach was quite lonely. However, as I say, ILSI has been there for the entire 21st century, and we have some of the publications here. And I remember very well that one of nutrigenomics opportunities in Asia, and we have seen already a representation of Singapore today, and that was back in 2005. And more recently, we have ILSI 2020, ILSI 2021, what you hear from Connie, and you will hear from me briefly, and also just today, this very moment. Precision nutrition has been in the mind, you can say that, of ILSI for a long time. So yeah, we have not been, our steps were not by ourselves, it was with the support of other people. It was not only ILSI that recognized the importance of precision nutrition, because NIH, in the strategic plan for 2020-2030, has identified precision nutrition as a major target, a major goal. And this has been beyond that booklet that very few people read about the strategic plan. We have things that people read more or are recognized more, like, for example, this precision nutrition, and I will read the title to you because you cannot see it probably. Precision nutrition, the answer to what we eat to stay healthy. And I could say that, okay, that sounds good. But when the former director of the NIH says that, people pay attention. And back in January of 2021, this paper was kind of translated into something to the public. And it was this meeting that we have, Precision Nutrition Research Gaps and Opportunities Workshop, sponsored by NIH, and I had the privilege of being one of the co-chairs. And from the conclusions of that meeting came this, because put the money where the mouth is. Yes, you can say that precision nutrition is the future, but if you don't grease the path to that future, it will never arrive. But yes, that's what NIH has done more recently this year, and it has awarded $170 million for precision nutrition study, the Nutrition for Precision Health. And it's really, really ambitious. And here we have a little bit the landscape of what this study is in terms of geography. So there is a bunch of different institutions and university institutions and so on, that they will participate with their expertise, whether it's in omics or as clinical sites or data analysis, obviously artificial intelligence and machine learning this time. So this is what is going to happen. And the root of that project was to make even better use of a population that study that was already ongoing, which is the All of Us study, which is a representative sample of the US of 1 million people that will be followed for as long as NIH wants to keep it funded. And part of that, a portion of that will be carved for this MPH study. And then, without getting into much detail, the first module in terms of collection, data collection, will be good, more than it has ever been done. And it will be in 12,000 individuals. And the second module, it will be providing diets to these individuals, different diets. And that will be over 2,000 people. And finally, the icing on the cake will be the third module, in which 500 people will be housed in metabolic units for weeks and weeks, receiving different diets and being tested 24 hours per day. So after 5 years, what we probably get will be algorithms that predict individual responses to diets. So we have not yet solved precision nutrition, because now those algorithms will have to be tested in real life. Are they working or not? But at least we'll be able to do that. Now, there is a caveat. Our emphasis is in preventing disease. That should be done as early as possible, although we have demonstrated that prevention works at every stages, each one of the stages of our life. But something that is missing from this study is here, indicating that, anyway, that the younger children, babies, children, adolescents are not part of this study, just because all of us doesn't have that population. So yes, we'll be able to understand better a segment of the population, but not all. But it's nice to see that there is no upper limit. So something that we hear before, that aging population will be represented. Okay. The other study that has already been, this will start. This is now in the planning period until January, February of 2023, the NPH. However, there are other studies that are ongoing, like this is the case of PREDICT. PREDICT is a wonderful sample of what we should be doing, which is involve academia and biotech, tech companies, right, together. And academia from different parts of the world. So here we have King's College, MGH, Stanford, Harvard, Tufts, and SOI based in London. And we have been producing already very interesting papers regarding or having the same purpose that MPH, algorithms, artificial intelligence, machine learning. And it was precisely this study PREDICT, the one that inspired the experimental approach for MPH. Something that is important is as we move towards the future in our steps, we turn around and we don't forget about our steps. Let's not just the waves erase all the work that we have been doing. So we have to build in knowledge that we have been creating, good or bad, in the past, and learn from the mistakes and use the good things that we have done in precision nutrition. One of the things that we have to recognize is that we live in an era of precision nutrition, and anybody, it doesn't matter the age, will recognize that when we are exposed to the either the popular press or advertisement or even our own scientific production, we are puzzled, right, by the difference in opinion, difference in results, and so we have to solve that problem. We have to remove the IM of that imprecision. Here is an example. It was June 2019, 3 years ago. Remember, red and processed meats can shorten life, say scientists. Well, if we say so, well, that's good. Well, we just have to wait a little bit, and we find Daily Mail. Sorry, vegans. Australian study finds eating meat correlates to a longer life expectancy. So that's what I mean by imprecision. And we are exposed to that, but the problem is that the entire population is exposed to that, and that's bad. And again, you will say, well, don't get confused by Australian study, because you will say, wow, this study was done in Australia. No, they used the same database that the previous study 3 years ago. It was just the covariance, the interpretation, you know. Yeah. Okay. So anyway, let's continue. In order to solve that, we thought that, well, let's just establish dietary guidelines for Americans, for Canadians, for Australians, for whatever, for everybody, and things will be clear. Well, maybe clear, but keep in mind that that changes over time. We don't change much over time, at least in 20, 30 years. But the dietary guidelines have been changing a little bit. The dietary guidelines are created for professionals. They are created for politicians. They are not created for the public. So for the public, you get the pyramid, you get the my plate, in order to make an easier communication. Well, we have been doing that for a few years, and things like obesity. Well, we see what happens with obesity, what happens to diabetes. So despite the fact that behind that is nutrition, those global nutrition recommendations, so as we tend to write it in our papers, one size fits all, is not having the expected beneficial impact. Moreover, as part of that imprecision and confusion that we have, let's keep in mind that there are more people that follow the influencers in social media that they follow the USDA or any office, or even us as scientists. The influencers, they have, 500,000 followers, and I don't know how many of followers you have in your social media, but probably not that number. And they are contributing every day, to this. So for the rest of the talk, I am going to use as a background the research opportunities. And rather than inventing them myself, we just published a paper that represents a little bit the consensus of that workshop in January 2021 that I mentioned earlier. And the first author is Charlotte Pratt, which is kind of orchestrating the nutritional efforts of the National Heart, Lung, and Blood Institute. And there were 4 major bullets, and I am not going to read them because I am going to go one by one on them. The first one is the need to explore the individual differences in response. Sorry, Connie, but we think that there are individual differences in response to dietary patterns and nutrients. And this is something that we have been, in most cases, very good about putting under the carpet. And that's what I say, somebody's trust is another treasure. For example, if you go to the publications in randomized clinical trials or in nutrition or any cohort and so on, you will see that it's presented always like this, that you see there. It doesn't matter the outcome. But just in case you put SEM, you don't put SD because, well, you get scared by the magnitude of the variability. So you just put SEM and things look much nicer. So this is something that it has been used, but it has been hiding what we are looking for, which is the exploiting that variability in the response to diet. And this is another example of my collaborator, Christopher Garner in Stanford. And this is something that we have presented many times, and is the diet fits study. And in this case, 12 months looking for weight loss in individuals, and it was either low fat or low carb diet. At the end of the day, at the end of the year, there was no difference, right? And obviously that's represented as SEMs, no SDs. But if you look at individual data, that's what you have. A huge variability in each case to each one of the diets in terms of weight loss. Okay, so for some people, the low-fat diet, it works like a charm, but for some others don't. They even increase their weight, and the same happens to the low-carb diet. So this is what really calls our attention in terms of saying, okay, one size does not fit all, and we have to identify who is who in this huge range of responses. And then provide that individual recommendation. And this is true for, I mean, that was in the US. I took another random example here in Europe from my collaborator, Dr. Holben in Norway. And in this case, it was not weight loss, it was LDL cholesterol. Well, it studied a number of people, and you see to the same diet, the variability in response to LDL cholesterol, to total cholesterol. You will say, well, are responders and non-responders? Well, responders and non-responders to each of the variables that you look at. Because if you look at the variability in response, or who responds to the diet for LDL cholesterol, and then you go down and, okay, so that matches the variability of the response in HDL cholesterol? No. So there is no parallelism between, you know, this person responds to lipids in the same way. No, each person responds in one way to LDL, another way to HDL, to triglycerides, and so on. So in summary, we are complex, and as it was indicated before by the previous speakers, also we have complexity in the foods that we have, and we have to keep those in context. It will get the time in which we'll be able to understand the complexity from both sides, the human and the food. I was mentioning before predict, and predict went beyond the fasting state that we are used in most studies, and it went to the postprandial. Why? Because in the postprandial state, that it happens that this is the most common state in humans, you amplify that variability, that response. So you can use this as a kind of acute challenge to identify who is responding and who is not responding. And that's precisely what I mean by the NPH, using this as a model, because the NPH from NIH, it focuses on the postprandial responses, which it was something that it was not very common in the past. We have been using postprandial challenges since the 80s, but most people have been using the fasting state because you control it better, and also they are easier to conduct. You don't need to have somebody in the clinic for the entire day in order to get samples. So the other thing that the other bullet from that paper from Dr. Pratt, it was that we have to investigate the basis: genetic, epigenetic, biological, social, psychological, environmental, and everything. So, I mean, we started with genetics, and I'm going to put you some examples about genetics. The other things are in progress, obviously. In terms of, let's take up low-hanging fruit, and I will use, for example, omega-3. If you go to the literature of the last few weeks, omega-3 fish oil, and I shouldn't be talking about those things in presence of our chair, we know that it's a common, it's very a common word in the title is controversy, controversy, controversy. You should think that after 40 years of looking at omega-3s, we should have it clear. But no, I mean, you can see what is happening, what is going on, especially with the results of clinical trials. Well, probably we will save a lot of ink, a lot of paper, if we just realize what we are pursuing. But it depends. It depends. And then in this case, you have very nice and clear genetic markers, which are that complex of fat genes, right? And even our genome has the plasticity of, depending on where you live, or at least where your ancestors have been living, you have a positive selection to take advantage of your food environment. And obviously the Eskimos will have a very different genetic profile when it comes to omega-3 that, for example, the Maasai in Africa. So nature, evolution has been taking that into consideration, but we have not been evolving to recognize the importance of that individual variation when it comes to interpreting the results of many of the trials that we conduct. Another thing that we have very clear, cast on stone, this is good, this is bad, okay? And obviously, when it comes to cardiovascular disease, for example, that's great, that's what you should be eating, and you should avoid this. Again, it depends. And we have been showing that for many years. For some people, that saturated fat, they can take it. And this is the example with ApoE2 that we published many years ago, and we published many papers in which, yeah, if you are either TT or TC for that specific promoter polymorphism in the ApoE2 gene, you can have a low saturated fat diet or high saturated fat diet, it will not have a major impact. Now, if you have the CC genotype, oh, now we are talking, because for those people recommending a low fat diet, a low saturated fat diet, avoiding those burgers, probably will be very good in order to either lose weight or prevent the gain of weight. And we have seen that in Framingham, in Salt Lake City, in Minneapolis, that's the Golden Study, or in non-white, Hispanic population, like in the Boston, Puerto Rican health study. And we have gone beyond the US, into Europe, same results, and into Singapore, same results. So this is one of those genetic markers that probably we can take it from the scientific arena and translate it into practical recommendations and applications, but not in isolation, because we have many other genes that will affect that response. When it comes to SSBs, we have the same situation. Yes, we have said, well, this is really bad. But again, it depends. Those are those are studies that are very well known in terms of coming from NIH, right? Large longitudinal cohorts. Let's go to the pooled information. And what we are seeing here is now we know the genetics of these individuals in those studies, and we can classify them according to having a high or low genetic predisposition to obesity. If you have a low genetic predisposition to obesity, then you are among those in which, yeah, you can increase your consumption of SSBs and nothing happens to your BMI. But if you have a high genetic predisposition to SSBs, be careful, because those, high predisposition to obesity because of your genes, those SSBs are going to make an impact on your waist and in your adipose tissue. Okay, so this is another example of personalized recommendations. Let's continue. Oh, cholesterol, for example. Back 1984, the cholesterol didn't have a good face, but later on, the DGAs decided, okay, it's not so bad. Well, again, it depends, because today, in 2022, you have both faces, but depending on who you are. In some cases, it's because of your genetics. In other cases, it's because of the genetics of your microbiota that is going to determine whether you can consume cholesterol safely or not. Okay, so, and we are going to talk, we are going to hear about microbiota, so I will skip this. And just to indicate that from PREDICT, we also identify a microbiome signature that is associated with good bags, bad bags, and it's great, right? Now, this is in the UK. That will translate, considering the complexity of microbiota, though that signature will be recognized in other parts of the world, we will see. And then the other aspect that it was in those bullets is that in addition to what we eat, we have to recognize the importance of when we eat. And this is an example also that is very illustrative, because this is a clinic in which people were going there to lose weight, and they were following a Mediterranean diet and some behavioral group advice and so on. And then some people did better than others. What is the difference? Not what they were eating. It's just when they were eating that meal. So if the main meal of the day. So if you eat late, you are less successful. So from the perspective of public health, you will say, okay, well, let's ask people to eat earlier, right? But let's go to the personalization. Let's put the genes in the middle. And here we have the variation in the perilipin-1 gene, which is the gene most expressed in the adipocyte. And then look at that. Because based on the variants in this gene, we identify people for which time doesn't matter. They can eat earlier, they can eat late, and they have the same success. But if you carry the AA genotype Now you see a huge difference, right? So again, personalized recommendation based on what we eat. And this is important given all these that we are seeing about restricted eating in one way or another. So that's something that will have personalized. And then applying implementation science, and I will cut off. In terms of precision nutrition interventions, and there are many ways. You can take the approach of 23andMe, artificial intelligence, machine learning, or you can take the approach that we hear from Dean Howe this morning about N of 1. And it's more complex. This is one of our studies in collaboration with our colleagues in China. And you can see the complexity, because here we combine different interventions with different doses in different order to capture the inter and intra-individual variability. The information that we get at the end of the day is huge for the individual. And again, if we aggregate that information, the result of that study, it doesn't matter what people eat, the response is the same. But if you look at the individuals' data, then you have responders and non-responders for each one. So we were able to classify these people in terms of what they should be consuming in order to manage their glucose response. Okay. And then we have, I will skip this, but we have a new initiative from ILSI in terms of precision nutrition that hopefully we'll hear in following editions of this. So just to finish, on one hand, we have this wonderful headline in that paper that I mentioned before from Rogers and Collins about the precision nutrition is the answer to what to eat to stay healthy. And then we have, this is from the same day. I look, and then you have people, this was June 22. Are personalized vitamins the future of wellness? It was a question. The answer was yes. Then you go to another side. Why is nutrigenomics the biggest flop in digital health? So that's what we have in the reality nowadays, and that's why it's so important to bring to the table first the research, the science, and then based on that research and science, then to bring all the stakeholders, scientists, the public, the governments, the private sector, and I think ILSI is in a unique position to bring those stakeholders to the table. Thank you so much.
Thank you, Jose. Brilliant as always. I see a hand up over here for a question. Oh, keep going.
Thank you. Excellent presentation. Scientifically, I absolutely adhere to what you're saying. However, our dietary advice at the moment is not terrible, yet few people follow it. Or follow it for periods of time, because we're actually not presented with saturated fat or sugar. We're presented with tasty foods, or food at every 5 meters type of issue. And how do you see the social transformation occurring so that we can actually get the health outcomes that this promises to offer? Thank you.
The short answer is we don't have the science. Yeah, the short answer to that complicated question is that we don't have time, but we can discuss that. That is why among those bullets is that we have to go beyond genetics. We have to go beyond all these omics that we are using, that technology, and we have to go after the education and the behavior of individuals. Otherwise, we'll be preaching in the desert, in that deserted beach of precision nutrition years ago. And but if we all combine efforts and we sit around that table and we cover also that segment of the population that is not present in all of us, which are the children, educate them, and we remove those food deserts that are all over the US, right? Yes, you have food every 5 minutes, but is that the food that we are going to recommend at the end of the day? Probably not. So, and that's why we can be publishing 1,000, 10,000 papers, and we can have all these meetings among the converts, right, or the choir. But if we don't reach people, and for that, we need the cooperation of first the educators, obviously, not first, but in any order, educators. We need the companies that produce those products to do it in a way that people trust those products, right? And don't think that they are just going after the economic benefit, right? So all those things have to be combined. And the other thing that I agree entirely is that we can be scrutinizing all the omics of the individuals. But if we don't have, on the other hand, what you were saying about understanding the complexity of the foods, and we'll hear more about that tomorrow, we are lost. And we have seen that, for example, in the old times. Now, Mediterranean diet, olive oil, extra virgin olive oil. In nutrition, we have made so many errors because olive oil is 1,000 different things. And if we don't standardize and know what is in that olive oil, we are going to get a whole spectrum of results. So that's why I don't know if that sun is very far away, that we'll never reach it, right? Or is the complexity is so huge that it just blinded us, right? Paralyzes us.
Okay, last question at the back here.
Yes, thank you. Very, very interesting. My name is Luke Pels, Look into Food, and I have a question related to what Dr. Hill was asking. You mentioned indeed that the food-based dietary guidelines don't work, but indeed, as you pointed out, they're not followed. Therefore, not much is happening. But so now I'm wondering, if I look from a distance, what are we actually doing? We have guidelines that are probably, if people would adhere to them, would have quite a big impact on public health and everyone's health. And they're quite simple messages, but people are not picking them up. So instead of working on making those happen in people's diets on our plates, we add enormous layers of complexity to what people are supposed to eat. And then we think then it will happen. And maybe that is because then every one of us feels special, and we like to feel special, and we like to be told this is specially for you, and then might be adhered to. So is it more a question of compliance to personalized nutrition, which will be much greater as compared to the one-size-fits-all of the dietary guidelines that's going to save us? How do you see this? Well, thank you.
Yeah, thank you for the question, because first, I already indicated a little bit about dietary guidelines. The fact that they have been changing and we have not changed, that already indicates that they may not be perfect. As humans are not perfect, right? And they are under the scrutiny. I am in one of the committees that is scrutinizing what is going on with how those DGAs are put to the, let's say, to the public. Yeah. We are going to see changes in the future. I don't know. We all have our biases, right? And but let's not get into that. The other thing that you indicated is about the complexity in our society. We want to, as you mentioned, feel unique. And if we feel unique, we may be more compliant. There has not been a lot of research done on that, but the research that has been published suggests that if you give a personalized recommendation, whether it includes genes or they work or they don't work, the people that receive those, the people in the arm that receive those personalized recommendations tend to adhere more to a healthier nutrition, right?